Surface currents are wind-driven. Wind energy is transferred to the sea surface by friction, generating surface currents on the surface layer of the ocean above the pycnocline. Global winds affect the movement of currents. At 45 degrees north, the westerlies blow from the southwest, pushing the surface layer of the water to the northeast. But due to Coriolis, the current is deflected eastward, creating the North Atlantic current. The teal arrow shows this surface current. At 15 degrees north, the trade winds will blow from the northeast, pushing the surface layer of the water in the southwest direction. But again, as a result of Coriolis, the current is deflected westward, creating the North Equatorial Current. The westward moving North Equatorial Current piles against the American continent, and it is deflected north, forming the Gulf Stream. The eastward moving North Atlantic Current piles against the European continent and is deflected southward, forming the Canary Current. These four interconnected currents with different flow directions and temperatures form the North Atlantic Subtropical Gyre. Subtropical gyres are present in all oceans and are made of large surface currents that move along the peripheries of major ocean basins. These currents transfer heat from tropical to polar region and influence weather and climate. Warm water currents occur on the western side of the ocean basins, and cold water currents on the eastern side of ocean basins, as a result of the global wind pattern in Coriolis. This interactive animated map is showing ocean currents and sea surface temperatures. The warm colors indicate warmer waters, and the cooler colors indicate cooler waters. Here you can see all 5 subtropical gyres and its surface currents. Let me point them out to you. These warm waters in the equatorial region of the Atlantic Ocean are carried poleward by a fast surface current on the western side of the North Atlantic Ocean. This is the Gulf Stream current. In the Pacific Ocean basin, warm waters from the equator are carried by a surface ocean current on the western side of the Pacific Ocean basin. This is the Kuroshio current. In the southern hemisphere, warm equatorial waters are carried southward by the East Australian current in the South Pacific and by the Brazil current in the South Atlantic and by the Agulhas current in the Indian Ocean. Now let's take a look at the cold surface currents. These travel on the eastern side of the ocean basins, and they carry cold waters towards the equator. Here's the Benguela current carrying cold water towards the equator. In the North Atlantic, we have cold waters traveling down the coast of Portugal and Northern Africa. This is the Canary Current. In the North Pacific, we have cold waters coming down towards the coast of California and Baja California in Mexico. This is the California Current. In the South Pacific, we have cold water currents coming up along the coast of Chile and Peru, and this is the Peru Current. Now, if I zoom out, you can see the pattern. Cold waters coming down on the eastern side of the Pacific Ocean basin, and warm waters flowing from the equator towards the poles on the other side of the Pacific Ocean. Let's take a closer look at the North Atlantic Ocean. The Gulf Stream current transports warm surface waters from the tropics to the North Atlantic. It will release heat to the atmosphere as it heads north. As a consequence, it moderates the climate at Great Britain. Take a look at the approximate temperatures for Great Britain and Newfoundland in Canada. Both are coastal areas at the same latitude, yet average February temperatures are quite different, with Great Britain having more mild temperatures as a result of the heat transport by the Gulf Stream. Last but not least, there is the Antarctic Circumpolar Current, or the west wind drift. Technically not a gyre, since it is not restricted by continents. The Antarctic Circumpolar Current, or the ACC, circles around Antarctica and is powered by the Southern Hemisphere westerlies.